we're going to evaluate our function from part 1. After finding our critical points and inflection points, we created domains or intervals in between each point, and then we're going to evaluate each point exactly to figure out what that is. So for y, when we evaluate our interval, we have multiple y values, correct? So we're not going to say much about this. We're just going to leave this out, and we're going to evaluate the intervals for y prime and y double prime, and then we're going to evaluate our points. So let's start off with y prime. So y prime, which is this equation right here, right? When x is less than -1 and goes to negative infinity, we have 12x to some negative number squared, so it's positive. And we have some answer where x is less than -1. So you get -2, -3, -4. So this part is always going to be negative. So you have positive, right, times a negative. So that gives you a negative, right? Let's do our x equals 1 or -1. When x equals -1, though, you have a -1 plus 1, which equals 0. So y prime is going to equal 0 at this point. Then from -1 to -2/3, we have something that's greater than -1 but less than -2/3. So here it's still going to be positive because it's even. And then here we're going to have 1 minus and some number that's a little bit less than 1 in absolute value. So it's going to be a positive number here. So even if we tried putting -2/3, we have 1 minus 2/3, which is still a positive number. So we know that y is going to be a positive number there. At x equals -2/3, this is still positive, like we said. Then from -2/3 to 0, we have some negative number still squared, and then some negative number just added by 1, but it's smaller than 1 in absolute value, so it's still positive. But at x equals 0, this whole thing will turn 0 because we have a 12 times a 0. So this whole thing becomes 0. And then from x is greater than 0 and goes to infinity, you have a positive and a positive, so you're always going to get positives. And let's do y double prime, which is this equation. This is going to test our concavity. So like we said in y prime, where we tested whether it's increasing or decreasing or it's a critical point, this is going to test whether it's concave up or concave down or it's an inflection point. So just so you can see that, when we have basically this right here, and we switch from being concave down to concave up, that's an inflection point. When we have a critical point, we have either a relative max or we have a relative min. And this is increasing and this is decreasing. So that's just some visualization so you understand what we're talking about when we are looking at these. So for y double prime, whenever x is less than -1 goes to negative infinity, we have a negative times a negative, which gives us positive. Then we at -1, we still have a negative. We still have a negative number overall, so we get also another positive. When x is less than -2/3 but greater than -1, we still have a negative here, and we still have a negative here up until -2/3 is what we'll see. So this will be a positive, right? And then for x equals -2/3, we actually get a 0 here. And if we look, this is one of our inflection points. We have 0. And then when x is greater than -2/3 and still less than 0, we still have a negative times a positive. So it gives us a negative. And then at x equals 0, this whole thing will equal 0, like we had our inflection point, right? And then when x is just straight up positive, we get a positive over here. So let's figure out, what does this even mean when we write it out? Well, here's what this means. When y prime is negative and y double prime is positive, that means it's decreasing because y prime is negative, and then y double prime is positive, so it's concave up. So concave up. Then when y prime is 0, this is a critical point. So y double prime will give us some information on what that means. So when we have a critical point, and then it tells us that y double prime is positive, so it's concave up, so the concavity is pointing upwards, this means this must be a relative min, right? So this is relative min. Then we have y prime. So it's positive. So if we have some function and y prime is positive, the slope is positive, so it's increasing. So this is increasing. And like we said, when y double prime is positive, we got concave up. So that looks something similar to this, where it's increasing and it's concave up, right? Then for here, we have y prime is positive. So it's increasing, the slope is positive, but y double prime is 0. So we have an inflection point. So we have some sort of point where the concavity changes and it's y prime is positive. So it may look something like this, where it's concave up here, concave down here, and the inflection point happens where y prime is actually positive. So that's something similar to what that looks like. So we'll say this is increasing. I'll also say it's an inflection point, right? And then for here, y prime is positive. So the slope is positive, but the concavity is down. It's negative. So this is increasing, and the concavity is concave down. And then here, when y prime is 0, so we have a critical point, but y double prime is also 0. So that's an inflection point. Something that may look like this is when you have your slope is equal to 0, and at the same time, you change concavities. So that's what that looks like when you have both are equal to 0. So we'll just call this an inflection point. And then finally here, we have y prime, which we meant to say is positive here. And then y double prime is also positive, so it's increasing. And it's concave up. So let's start sketching this to some extent. So if we try to sketch this on a graph, we have it's decreasing and concave up until x equals -1. So up until a point where it reaches -1, x equals -1, it's decreasing and concave up. Then at x equals -1, we have a relative minimum. So this is going to be a relative min, right? Then it's going to be increasing and concave up. So it's going to look something similar to this. And then up until -2/3, and then after -2/3, we're going to have increasing, and then at -2/3, you have increasing and an inflection point, and it's going to be increasing and concave down, so it's going to look something like this, until it reaches x equals 0, which is an inflection point, and then let's go back to increasing and concave up. So something similar to this. So we have concave up here, concave up here, then we have concave down up until here. We have a relative min here. We have an inflection point, so inflection point, and then another inflection point. And that's how you sketch this curve.